we're going to talk about working backwards with hyperbolas and ellipses today. And then we're going to spend the next couple days reviewing for our test. Okay. You're going to have a test on Thursday, and then your 4-day weekend, you won't have any math responsibilities. Okay. So for ellipses and hyperbolas, they're pretty similar. Okay. So let's talk about what their standard forms look like. Okay. Let's first consider ellipses. We have horizontal and that's not what I want. Vertical ellipses. Okay. If we have a horizontal ellipse, then our standard form is x minus h squared over a squared plus y minus k squared over b squared equals 1. Remember, in ellipses, A is bigger than B. So A is telling us which direction we are opening. So vertically, the smaller denominator is going to be with the x, and the larger denominator is going to be with the y. For ellipses, how do we find C for our foci? C squared is a squared minus b squared. Just forgot the square, okay? That's going to be important today. Okay. All right, let's talk about our hyperbolas. They're pretty similar, right? Our standard forms. If we have a horizontal ellipse, excuse me, hyperbola versus a vertical hyperbola. Okay, the only difference, well, there's a couple differences. A and B, doesn't matter how big they are. What matters is who is the positive variable and who is the negative variable. A squared is always with the positive variable. Okay. A and B can be any sizes, doesn't matter who's bigger. However, when we identify our ellipses, C squared is A squared plus B squared. So I actually think working backwards is easier than graphing. Okay, and you guys did a pretty good job on graphing. I know there's a couple things that we needed to work on. Some of the algebra we needed to work on. And we'll get that work in this week, but I'm actually going to have you do our first 2 examples. I'm not going to lead you through these. We'll talk about them together, obviously. But number 1, we need to wake up a little bit. So let's get to talking with our peers. Okay. Number 2, I think you can do this without me. So I have 2 examples here. One is an ellipse, one is a hyperbola. Both of them, I am giving you the vertices and the foci. So what you need to do, you need to figure out, is this a horizontal or is this a vertical ellipse or hyperbola? You need to figure out the center, you need to figure out A, you need to figure out B. Once you have those 3 things, you'll be able to write your equation. So I'm going to give you about 5 minutes to see what you can do with these 2 problems. And then obviously we'll talk about them together, but I'd like to see what you can do first. Okay. What's going to help if you draw a picture? Draw a picture. Tajik. each other. We didn't even draw it. But what do you know? You know what the center is? Okay. Do you know A? A is how far the vertices are from the center. Okay. A is the what? Okay. C is how far away the foci are from the center. Your B is with those two. Okay, you just drew it. Okay. We're gonna try to figure it out what's going on. Horizontal or vertical? Horizontal. Okay, so the A squared needs to go under the X squared. Now, if you know that C is 2, but you know what? You wouldn't even need to solve for B as long as you know B squared. That's going to be in your denominator. You know what I mean? Like you need 32 as a denominator.
You have to like do all the like get it on top.
Well, it would be 32. Yeah. Because this is B squared. And if this is B squared is 32. You see what I'm saying? We'll never be making that.
I was thinking, you know, because C squared is 4. It's gotta be subtracted. Oh, it's always.
But let me give you a hint. I'm gonna give you a timeout real quick. For your standard form, do you need B or do you need B squared? You need B squared, right? So if B is radical 32 and you're doing all this work to reduce it, you don't really need to. In your equation, you just need B squared. So solve for B squared. Don't take the square root. Just solve for B squared and stop. You see what I mean by that?
Yeah.
Okay. I give you about 1 more minute before we talk about these, okay? in this first one, number 1, where's our center? At the origin, okay? Our center is in the middle of where our vertices are, okay? We know this is horizontal because vertices are horizontal from each other. Okay, what's A? What's A? 6. Our vertices are 6 from our center. The foci are 2 away. That gives us C. And if C squared is A squared minus B squared, then B squared is what? 32. And we stop. You don't actually need to take the square root because we can write x squared over 36 plus y squared over 32 equals 1. And that's what we need. Okay. Actually saves you a step of reducing a radical. Okay. Right? How about the second one? Once again, our vertices are vertical, or excuse me, horizontal from each other. So we know that it's a horizontal hyperbola. Okay. In between the vertices, our center is at 0, 0. That's kind of boring. It's fine. Our vertices are how far away? Our vertices are how far away? 4. A is 4. Our foci are how far away? 6. Now C squared is A squared plus B squared. So C squared is 36. A squared is 16. What does that make B squared? 20. So we can simply write x minus 0 squared over 16 minus y minus 0 squared over 20 equals 1. Less work than graphing, right? All right, let's do some together. Okay. Write down what you need to here. So we have foci at 0, 0, and 4, 0. And we have a major axis that has length 8. So I've given you 2 foci and I've given you the major axis length. Write down what you need to. Okay. So our foci are 0, 0, and 1, 2, 3, 4, 0, right? Okay, that tells us a lot of information right there. First of all, is this horizontal or vertical? Horizontal, because our foci are horizontal from each other. So we know that we're going to have x minus a squared over a squared minus k squared. Okay, it tells us something else. What else does it tell? Well, it tells us 2 more things. What's another thing it tells us? Our center is where? Our center is at 2, 0. Cool. And now that we know what our center is and we have the foci, what does that tell us? And what is C? What's the number for C? 2. Okay, our foci are 2 away from the center. Okay. The major axis has length of 8. Isaac, what is that going to help us figure out? Okay, if our major axis has length of 8, how far are our vertices from the center? 4. Our major axis is double A. So A is 4. Cool. Well, now we can use the fact that C squared is A squared minus B squared, and we can figure out our B squared. C squared is 4, A squared is 16. What does that make B squared? What does that make B squared? So we have x minus h squared over a plus y minus k squared over b squared equals 1. And I'm always going to stop at b squared, or if we're solving for a squared. I don't really need a, I don't really need b. For our equation, we need a squared and b squared. Okay. All right, let's do a hyperbola. We have vertices at -2, 1, and 2, 1. And it passes through the point 5, 4. Ooh, I feel like we're gonna have to do some algebra here. What do you think? All right, so -2, 1, and 2, 1 are our vertices. Hey, Joby, is this horizontal or vertical hyperbola? Look at my picture. Okay, our vertices are horizontal from each other, so we have a horizontal hyperbola. Okay. Apparently, I really wanted horizontal stuff today, huh? Okay. Finn, where's our center going to be? Sure. 0, 1. That sounds better. Okay. Our center is at 0, 1. And we're going to know A from this. Okay. Luke, what's A? How far are our vertices from our center? 2. Do we know C? Yes or no? Do we know C? No, we have no information about foci. Do we know B? No, we have none of that information. But we have a point on the curve. So we know that we can come in here and we can type in 0, 1 for our center. And we know that our denominator over here, if A is 2, A squared is 4. We need B squared. And we have a point on the curve. Guess what we get to do? What are we gonna do? We get to plug it in. Okay, so we have 5 minus 0 squared over 4 minus 4 minus 1 squared over b squared equals 1. Okay, so we have 25/4 minus 9 over b squared equals 1. Okay, we got to solve for b squared. So let's subtract this 25/4 over here. 1, aka 4/4 minus 25/4 is going to give us what? Negative 21/25? No? Okay. You're shaking your head, you don't like it? That makes more sense. No. Because then I'd be multiplying this to b. Okay, now, sorry about that confusion, we can cross multiply. 21b squared equals 36. So b squared is 36 over 21. What I did now. Well, this is 1, so this is like 4/4. And we subtracted the 25/4 to get negative 21/4. Okay, cross multiply to get 21b squared equals 36. Divide that over. And we don't have to worry about solving for b, okay? Because now we can write that x minus, well, do I have to write 0? I can write x minus 0 squared over 4 minus y minus 1 squared over ugly 36 over 21 equals 1. A and B are not always pretty numbers, and that's okay. Yes. Oh, we can, can't we? Probably a good idea. Yes, let's do that. What does it simplify to? 12 over 7. I do like reduced fractions. You are right. Thank you, Hank Kriegler. All right, we have 11 minutes left. I have 3 examples, but maybe 2 of them will be what we go through, okay? Are you ready? Okay. It says you do it, but we're gonna go ahead and let's not worry about this one right now. Okay, so the center is 3, 2. E is 1/3, and the foci are 3, 0, and 3, 4. So our center is 3, 2. 3, 0, and 3, 4 are our foci. Kristen, what kind of ellipse do we have? Vertical or horizontal? We have a vertical ellipse because our foci are vertical from each other. Okay, well, we have our center. That's good news. Our center is at 3, 2. Our foci, ooh, what does that give us? C is what? C is 2. Interesting. Well, this could be a reduced fraction, right? So let's talk about that. So from this, our foci are 2 away from the center, and that's really how we get our C value, right? Now, eccentricity is C over A, correct? So eccentricity is C over A, and we know eccentricity is 1/3, and we know that C is 2. So what does that make A? Ah, yes. So we have x minus 3 squared over, oh shoot. Oh, we don't know B, do we? We know A is 6, so A squared is 36. How are we gonna figure out B? What? Okay, we have C and A, right? So we know that C squared is A squared. We have an ellipse, it's minus. Okay, so C was 2, A was 6. What does that make B squared? Yes.
You were going really fast. Why can't A be 1? Because isn't it A over C?
C over A.
So why can't A be 3?
Because C, so this, it could be a fraction that's been reduced. So this could be 3 over 9. It could be 21 over 63. You see what I'm saying? So we know this is a fraction C over A, but from our picture, our foci are exactly 2 away from our center. So we know C is exactly 2. So then when we use C in our eccentricity fraction, that's going to mean A is 6, and then that reduces to the 1/3. Does that make sense? Okay. Okay, we're not going to do this example, but I want to talk about just something real quick. Oh. If we have minor endpoints, that's going to give you what letter? A, B, or C? B. All right, cool. All right, I really wanted to make sure we got through this one though. We have a hyperbola. I have vertices and I have asymptotes. Yes. Write down what you need to, and this is what we're going to end our day on. All right, reach a vertical or a horizontal? Vertical. Our vertices are vertical from each other. So we are going to have a vertical hyperbola. So we have y minus k squared over a squared minus x minus h squared over b squared equals 1. All right. So what's some information that we know? Since our vertices are there, where must our center be? In between them. Our center is at 3, 2. All right. What else do we know? Our vertices are how far away from the center? 2. So A is 2. We don't have any information about the foci, so we don't even have to worry about C. I don't care what it is, but we do need to figure out B in order to be able to fill in this guy right here. Now, our asymptotes are y equals 2/3 x and 4 minus 2/3 x. Now, that's not usually how we write our asymptotes, and that's okay. But what? Okay, we know that the slope of our asymptotes is either going to be A over B or B over A, depending on if we have vertical or horizontal. Okay, so I know we don't know where our box is, but we do know that these have rise of 2, run of 3. Ooh, and we know that A is 2, right? So if our slope is 2 over 3 and A is 2, what do you think B is? Ah, cool. So we have y minus 2, the quantity squared over 4, minus x minus 3, the quantity squared over 9 equals 1. We still have 2 entire minutes. I don't know why you're so worried and in a hurry to pack up. We have plenty of time. Finish the example. Okay, so your homework assignment comes from 2 different pages because you need to practice ellipses. You need to practice hyperbolas. Okay. Tomorrow, we're going to focus on concentrating on the algebra part of our test. Like, hey, here's an equation, put it in standard form by completing the square. We need a little extra practice with that. So that's what we're going to spend most of tomorrow doing. And then you'll walk out of here with your chapter review. Okay. Your test, I'm pretty sure, is like 9 or 10 questions. Well, there's a lot of points available though, right? You have 3 graphs, you have 3 complete the squares, you have 3 working backwards, and then I have a question where I ask you, is this what kind of, like, here are equations. Is it a parabola? Is it a circle? Is it a, what is it? That's it. Okay. So I know it's not very many questions in your mind, but like a graph, doing a graph is like 7 points because you have to do all of the identifying and do the graph and that kind of thing. Okay. Now, I know you're tired.